And we're just waiting for my writing. Unconnected. Should I try it again? I don't know, I see it moving. All right, let's try it again. And by the way, all of these have been in your note. I think almost all of these are in your notes. I'm sure this one is. So you just look through and make sure, right? And you can always do a screenshot, and if you're not sure, and then look for it in your notes. All right, so g of x equals, so we have cosine 3x, and all of that is squared. That's what that means. All right, so we're going, when we take the derivative, we're going to take the derivative of, that's d dx there, we're going to take the derivative of the blob squared, right, and we don't care what's in the blob. Then we're going to take the derivative of the cosine blob, right, because cosine 3x, there's two functions there, there's cosine and there's 3x. And then, I'm encroaching on the next box, we're going to take the derivative of the 3x. All right? So we're going to do all those things in this chain rule. And it's, you'll get the hang of it. It's really not too difficult once you get the hang of it. Oops. No, I just wanted to move you over. There we go. Now we're not in the other box. All right, so g prime of x equals, all right, so the derivative of blob squared is 2 blob. So this would be 2 times, and actually I really don't need the parentheses, so I'm not going to use them. 2 times cosine 3x times the derivative of cosine x. That's going to be, I'm going to use parentheses here because I don't want it to look like, if I don't use parentheses, it's sine blob. Yeah, if I don't use parentheses, it might look like a subtraction rather than multiplication. All right, so the derivative of cosine blob is negative sine blob. The blob is, of course, 3x. And then we need to take the derivative of the 3x. So the derivative of 3x is 3. Now let's multiply all these coefficients together, the negative 2, the negative 1, and the 3, and put that in front. And then we can drop the parentheses. So that would be negative 6 cosine 3x sine 3x. And there we go. I kind of like these parentheses, though. Just visually, I like those better. All right, and there we go. And that's all we were going to do here is find the derivative. Let's find the derivative of sine squared, 2x plus 1. All right, so it helps to rewrite this as h of x equals sine 2x plus 1, and that is all squared. All right, so we're going, h prime of x is going to be the derivative of blob squared times the derivative of sine blob, and then times the derivative of the 2x plus 1. All right, so h prime of x equals, the derivative of blob squared is 2 blob. What's the blob? The blob is, I just wanted to make sure I didn't make an error. I was just glancing over at the other one because this one is much longer. Just wanted to make sure. No, I have cosine 3x. It's okay. There, and this one, the blob is sine 2x plus 1. Yeah, parentheses. Times the derivative of sine blob. The derivative of sine blob is cosine blob, and the blob is 2x plus 1. And the derivative of 2x plus 1 is 2. Let's multiply all the coefficients together. We have a 2 and a 2 here. That's it. So h prime of x equals 3 sine 2x plus 1 cosine 2x plus 1. And there we go. We have found the derivative of sine squared 2x plus 1. Right? So if you've got a composite function, use the chain rule. You know, take the derivative of the outside and work your way in, and you won't make a mistake.
Hector De La Rosa, please make your way
Sorry
to the
about
front
that.
office. Your ride is waiting. Hector
So,
De La Rosa, please
you
come to
know,
the front
now
office.
you
Your
know
ride
the
is waiting.
3 big rules of differentiation. the product, the quotient, and the chain rule. Those will get used the most, and they get used in conjunction with other rules as well. Let's see how the three can be incorporated with each other. Find the derivative of each of the following. And this is in your notes. Just look for the big three there. All right, so this one is the product rule. We have f of x equals 5x times the square root of x plus 3. The product rule, remember, is the first times the derivative of the second plus the second times the derivative of the first. All right, and on ones like this, it's helpful to find each of your derivatives separately. Like on the other one, I don't mind, working my way over and just, writing down the derivative of the next part. But on these ones, I think it's helpful to just write everybody down. So u is 5x. That's an easy derivative. It's just 5. V is, let's rewrite that. That's x plus 3 to the 1/2 power. Right? And so dv, now we can use the power rule. dv is going to be 1/2 times x plus 3 to the negative 1/2 power. Actually, let me write everything out. I don't want to lose anybody. All right, so we're going to, our derivative here is going to be, we're going to take the derivative of block to the 1/2, I think I was going too fast, times the derivative of the x plus 3. Because that's a really easy derivative. I think I was going a little fast, though, I don't want to confuse anybody. So dv equals, all right, so the derivative of block to the 1/2 is 1/2 block, and then 1/2 minus 1 is negative 1/2. And of course, the block is x plus 3. The derivative of x plus 3 is really easy because it's just a 1. So let's rewrite this. So we have a 1 in the numerator and 2 square roots of x plus 3. If it's complicated, I'll leave it as a rational exponent, but I think it looks a little nicer with the radical there. It's totally your choice. All right, so now we have the derivative. So now let's find the derivative of the whole function. So f prime of x is going to be the 5x times the derivative of the square root of x plus 3. So that's going to be the dv there. So that's going to be times 1 over 2 square roots of x plus 3. And then, I took up so much space going sideways. Maybe if I bring some of this down. I don't have enough room for the derivative. Why do I keep moving the problems? All right, fine. I'm going to lock you in place. And now, without any problems, I can move this down. There. All right. So the derivative is going to be 5x times 1 over 2 times the square root of x plus 3, and then plus the derivative of the first one, which is 5, times the second function, which is the square root of x plus 3. And we're just going to be able to do a little bit of simplifying. So f prime of x equals, let's multiply, so let's put the 5x in the numerator, and the 2 square roots of x plus 3 in the denominator. And then I am fine with this being these two terms there. So 5x divided by 2 square roots of x plus 3 plus 5 times the square root of x plus 3. I wouldn't worry about getting a common denominator. If this were a multiple choice test and you didn't see your answer, then maybe they got a common denominator and combined it as one fraction, but this is fine. All right, let's try the next one. All right, so we have a composite here, but the inside function is a quotient rule. So as a reminder, the quotient rule right, so the quotient rule, if you've got u divided by v, it's going to be v times u prime minus u times v prime, I hope my u's and v's look different, divided by v squared. Or low d high minus high d low over low. All right, so let's find that derivative separately. So we want the derivative of, actually let me use a different color. We want to take the derivative of the 2x plus 1 over x minus 3. So the u is 2x plus 1, du is 2. The v is x minus 3, dv is 1. So these are nice, easy derivatives. Right? So we have the derivative just of this part. Right? I'll just put dy dx here. Equals, so we have the denominator, which is x minus 3, times the derivative of the numerator, which is 2, minus the derivative of the denominator, the numerator times the derivative of the denominator. So that's going to be 2x plus 1 times 1. All right, all over x minus 3 squared. All right, let's just expand. Let's just distribute and combine like terms. So dy dx equals, we've got 2x minus 6 minus 2x minus 1, right? Because if we multiply by 1, it's not going to change. All over x minus 3 squared. So that's going to be negative 7 divided by x minus 3 squared. Sorry, I was teaching a class, and whenever I talk a lot, I cough a lot. So the coughing is just, it wears out my throat and my voice. So now I'm all coffee. All right, so now let's find the derivative of this one. So we have g prime of x. It's going to be the derivative of sine blop times the derivative of the blop. And of course the blop is 2x plus 1 divided by x minus 3. And we have figured that part out. All right, so that's why it's good to have that off to the side, because that's, you kind of want to do things separately. If you're trying to do everything at once, sometimes it gets too confusing. Right? So g prime of x equals, right, so the derivative of sine blop is going to be cosine blop. So cosine times 2x plus 1 divided by x minus 3, and then times our derivative of the inside, which is negative 7 over x minus 3 squared. The only thing I would do is change the order. I don't like to have anything on the other side of cosine. It gets confusing looking, and it looks like, what are we taking the cosine of? I don't know. Let's just move that one term in front. So g prime of x equals negative 7. And what we could do is put everything in we could combine, you either could just put this as a coefficient in front. Yeah, I guess that's the nicest looking thing we can do. Rather than putting cosine in the numerator up with 7. I think it might look nicer just to do negative 7 times x minus 3 squared, and then times cosine 2x plus 1 over x minus 3. Right? That looks, I think, a little nicer than it looked on the line above. And that's it. That's the derivative. All right? So if you've got if your inside has a complicated derivative, do that separately. All right, so here we have a composite with a quotient rule. All right, let's find the derivative of the composite part first. So in other words, let's find the derivative of the numerator. So we're taking the derivative of the 2x plus 5 to the 1/2 power. I've already rewritten that as a rational exponent so that we can differentiate. So that's going to be, a little glitch there. That's going to be 1/2 blop, right, to the negative 1/2 times the derivative of blop. And the derivative of blop is, we're taking the derivative of the 2x plus 5. All right, so our derivative for the inside part is going to be, we got 1/2 times, and I'll write it like this, 2x plus 5 to the negative 1/2, and then we'll simplify it. And then the derivative of 2x plus 5 is just the 2. All right, the 2 and the 1/2 cancel, so then the derivative of the numerator is going to be 1 over the square root of 2x plus 5. All right, I wonder if we're going to have some complex fractions to simplify on this one. All right, I guess we can just start now that we have the derivative. So this is u prime, right? This is the derivative of the numerator. Just as a reminder, this is the quotient rule. All right, so our derivative of a quotient is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. All right. So we have h prime of x equals, right? So the denominator is x minus 3. Oh, I hope everything fits. Times the derivative of the numerator. Well, that's times 1 over the square root of 2x plus 5. And then minus we didn't do the derivative of the numerator, the derivative of the denominator, but that one's pretty easy. So v prime. So if v is x minus 3, v prime is just 1. So we have minus 1 times the square root of 2x plus 5 all over x minus 3. All right, let's simplify this a little bit, and we're going to have to get rid of that complex fraction. H of x equals, so we have x minus 3 divided by 2x, the square root of 2x plus 5, minus the square root of 2x plus 5 divided by, our x minus 3 needs squaring. X minus 3 squared. Now we can make this not be a complex fraction anymore by multiplying by the least common denominator. So I'm just going to put that a little note there. Multiply every term by the least common denominator to eliminate complex fractions. All right, so we're going to multiply this one by the square root of 2x plus 5, and this one by the square root of 2x plus 5, and this one by the square root of 2x plus 5. So that's going to give us h prime of x equals, all right, so now the 2x plus 5's will cancel. This is now just x minus 3 minus, all right, so the square root of 2x plus 5 times the square root of 2x plus 5, that is just 2x plus 5. And don't forget, we're subtracting all of that, so we need parentheses so we remember to distribute. And then in the denominator, we're going to have x minus 3 squared times the square root of 2x plus 5. We are fine with the radical in the denominator. We don't want that complex fraction, but that radical in the denominator is fine. It's not a big deal. H prime of x equals, right? So that's going to be x. Actually, let me just do it up here really lightly, and then we'll just write the final answer because we're starting to run out of space here. So this is going to be a negative 2x and a negative 5. It's nothing really complicated. I think we can do that in our head. So x minus 2x, that's going to be a negative x. And negative 3 minus 5 is going to be negative 8. So we have negative x minus 8 divided by x minus 3 squared times the square root of 2x plus 5. And there were a lot of parts to this, but we got it down, right? Just do it separately, take your time and simplify. Right? And I think this is a good place for me to end this podcast, and I'll start the next problem on the next video. All right, thanks for watching. Bye for now.